This week's lesson is on ultraviolet waves, X-rays and gamma rays. Have a look at the characters given and think who is the odd one out and why. So write down the names. Some of you may not know the names of, so you may want to have a look at that on the internet beforehand, but just state which one's the odd one out and why. You may want to write down what each character does, and then that will help you identify the odd one out. So give you a few more seconds, make sure you pause it and have a go, and then I'll reveal the answer in a moment. So Superman is odd one out because he is classed as an alien. Spider-Man was bitten by a radioactive spider. Dr. Bruce Banner was exposed to gamma rays. Both Radioactive Man and Godzilla were close to the detonation of an atomic bomb. And obviously Superman came from Krypton, I believe. Your lesson objective this week is to understand the properties and uses of ultraviolet waves, X-rays and gamma rays. Your key words are the word penetrating, which we've come across before, ionisation, which we've come across before when we looked at radioactivity, and another key word of absorption. So, for grade 4, you need to state the uses and dangers of ultraviolet waves, X-rays and gamma rays. Grade 5, describe the penetrating powers of gamma rays, X-rays and ultraviolet waves. Grade 6, compare the origins of X-rays and gamma radiation. Grade 7, compare different regions of the electromagnetic spectrum in terms of their potential harmfulness. In Grade 8, explain how the process of ionisation can lead to cell death or cancer through damage to DNA. So by looking back at this, or when they're recapped, it allows you to see how confident you are and what grade you have reached for this lesson. So this shows your topic learning route, so what's been covered so far and what we are now on. So your next lesson will be on X-rays in medicine. Discovering where ultraviolet rays come from. So ultraviolet waves lie between violet light and X-rays in the electromagnetic spectrum. UV wavelengths are smaller than visible light wavelengths. UV waves carry more energy than visible light waves, and UV frequency range is from 8 times 10 to the power of 14 to 3 times 10 to the power of 16, and this is measured in hertz. So again, you're given the numbers because some of us struggle a little bit when we're looking at standard form and their real numbers. There are so many different uses of UV waves. So the first one we'll look at is chemicals. Some chemicals emit light as a result of absorbing the ultraviolet waves. So you can see some of the chemicals given on the screen, how they're different, like luminous colours. Inks, so posters and inks that glow in ultraviolet light contain these particular chemicals. So the poster given on the screen shows that. And security pens, so security marker pens contain this kind of ink and they're used to mark valuable objects. So for instance, some people may place this on the back of their telly, and that would allow, if their telly was to be robbed in a burglary, if police find a certain type of telly and use a UV light to have a look at their security pen that was placed on there, that can identify that it does belong to that particular household. So the chemicals absorb ultraviolet waves and emit visible light. Dangers of ultraviolet rays. So ultraviolet waves are harmful to human eyes and can cause blindness. Ultraviolet rays are harmful to your skin. For example, too much UV directly from the sun or from a sunbed can cause long-term damage. It can also age the skin prematurely, as well as sunburn and skin cancer. There's actually a law in place now where anyone under the age of 18, it's illegal for you to use a sunbed, and if you're using a sunbed over the age of 18 onwards, you need to ensure that you're wearing goggles to protect your eyes from harmfulness from the UV waves, which was said earlier that it can cause blindness. Protection from UV rays. If you stay outdoors in the summer, you use sun creams to block UV waves and prevent them from reaching your skin. You have SPF factors 15, 30 and 50. There is a rational reason why the SPF numbers are what they are. They indicate how many multiples of times you're safe to be out in the sun before you burn. The Skin Cancer Foundation describes it like this. If it takes 20 minutes for your unprotected skin to start turning red, using the SPF 15 sunscreen theoretically prevents reddening 15 times longer, so that's about 5 hours, and it makes total sense. SPF 15 will give you 15 times the number of minutes before you burn than you'd have with no sunscreen protection at all. As mentioned earlier, if you use a sunbed to get a suntan, don't go over the recommended time. You should also wear special goggles to protect your eyes. Question check. I'll read out the questions, you then pause and then have a go, and then please ensure your green pen. If you're typing, can you try and give yourself a tick or state correct, or state the correct answer if you've got it incorrect, please. What light lies between violet light and X-rays? That's grades 1 to 2. What is the frequency range of this light? That's grades 2 to 3. What can ultraviolet light be used for? So pause, have a go at the questions please. Then I'll go through the answers in a moment. If you're typing, use green pen. If you're writing it down, use green pen please. But you need to show what your idea of the answer will be and then your reflection on it, because a few people are not doing so. So answers. So UV light is what lies between violet light and X-rays. Frequency, as mentioned earlier, 8 times 10 to the power of 14 Hz to 3 times 10 to the power of 16 Hz. What can ultraviolet light be used for? To mark valuable objects that under UV light they can be identified, to make pictures or signs that glow when UV light is shone on them. Question check, grades 4 to 5. What are the dangers of UV light and how do we protect ourselves from it? So again, pause, place your ideas in bullet points because that's effective in stating your points, and then self-assess in green if you're typing and self-assess in green pen if you're writing this down. So I'll give you a couple more seconds, just pause, and then I'll go through the answers. So ultraviolet rays are harmful to the skin. It prematurely ages the skin, burns the skin, can give you skin cancer, damages eyesight. So in order to protect yourselves from it, you'd need to use skin creams that block UV light, cover skin with clothes, don't spend too long on a sunbed, and wear UV filtered sunglasses. X-rays and gamma rays have similarities and they're next to each other as well in the electromagnetic spectrum. So they're both at the short wavelength, and as stated, they're at the end of the electromagnetic spectrum next to each other. They transfer much more energy per second than longer wavelengths of electromagnetic waves. They can travel straight into substances that can go through them if they're not too dense or thick, and a thick plate made of lead will stop them. So you were actually shown gamma rays in school when we did radioactivity. So you should have seen the fact when lead was placed in front of the gamma, that obviously stopped it. X-rays and gamma rays are different from each other because X-rays are produced when electrons or other particles moving at high speeds collide with a metal target. X-ray tubes are used to produce X-rays, so you're shown in the diagram on the right hand side. Gamma rays are produced by a radioactive substance when unstable nuclei release energy. Gamma rays have shorter wavelengths than X-rays, so they can penetrate substances more. So as you can see at the diagram, the gamma rays going through the solid material can penetrate the substance more than the X-rays shown travelling through the solid material. Average distance to stop or absorb gamma rays is 0.4 meters of lead. The thickness to completely stop or absorb X-rays or gamma rays will vary depending on A. The distance from the original source of gamma rays or X-rays, B. Original intensity of source of gamma rays or X-rays, C. Density of the protection material. Question check. Again, you've got the option of working on the worksheet if you prefer and answering the questions on there as we go along, or if you're happy to do it as we do it in small snippets on here and doing it by yourself without the worksheet, that's absolutely fine. What are some similarities of X-rays and gamma rays you've shown earlier? That's grades 3 to 4. Describe how X-rays are produced. That's grades 4 to 5. Again, just pause. I'll go through the answers in a short moment and then you can self-assess your answers. Similarities: short wavelength, transfer the highest amount of energy, can travel through solid materials if not too thick, thick plate of lead will stop both rays. So describe how X-rays are produced. When electrons moving at high speeds collide with a metal target, X-ray tubes are used to produce X-rays. Our next question check. Describe how gamma rays are produced. That's grades 4 to 5. Describe the penetrating powers of gamma rays and X-rays and how to protect against them, which is grades 5 to 6. So I'll give you a couple of seconds and then we'll go through it. Make sure that you pause so it gives you the amount of time that you need. Gamma rays are produced by a radioactive substance when unstable nuclei release energy. So to describe the penetrating powers of gamma rays and X-rays and how to protect against them, gamma rays penetrate substances more. Highest energy, they have the shortest wavelength than X-rays. Gamma rays and X-rays stopped by thick lead has to be about 0.4 meters. Thickness of a substance for protection will be dependent on distance and intensity of original source, density of substance. So far we should have covered grades 4 and grades 5. We're now going to move on to grade 6. Using X-rays. Most students forget that X-rays can be used to detect internal cracks in metal objects. The more dense an object is, the more X-rays it will absorb. Black equals 0 X-ray absorption. Bright white equals 100% X-ray absorption. X-rays are used in medicine to create images of, for example, broken bones. So that is the main use students always say, but if you needed to state another one, ensure that you know X-rays can be used to detect internal cracks in metal objects. Using gamma rays. About 20% of the world's food is lost through spoilage, mostly due to bacteria. Bacteria waste products cause food poisoning. Exposing food to gamma rays kills 99% of disease-carrying organisms. Exposing surgical instruments sealed in plastic wrappers before exposure to gamma rays kills any bacteria on the instruments. Doctors and medical physicists use gamma ray therapy to destroy cancerous tumours. A narrow beam of gamma rays, cobalt-60, is directed at the tumour. It kills the tumour but not the surrounding tissue. So again, most students know the fact of gamma rays destroying cancerous tumours. They tend to forget the uses of surgical instruments being cleaned by gamma rays and the fact that they're used on food as well. So again, if you're asked for 2 uses of gamma rays, make sure you've got 2 that you remember the best. Most people, as I said, remember the one of it destroys cancerous tumours. Safety matters. X-rays and gamma rays passing through substances can knock electrons out of atoms in the substance. The atoms become charged because they lose electrons. This process is called ionisation, and we briefly covered it in radioactivity topic. If ionisation happens to a living cell, it can damage or kill the cell. For this reason, exposure to too many X-rays or gamma rays is dangerous and can cause cancer. High doses kill living cells, and low doses cause gene mutation due to the DNA damage and cancerous growth. People who use equipment or substances that produce any form of ionising radiation, so for example X-rays or gamma rays, they must wear what is known as a film badge, which is shown on the first picture on the right hand side. If the badge shows that it is overexposed to ionising radiation, its wearer is not allowed to continue working with the equipment for a period of time, so that's the safety of protecting them from the radiation. Question check, grades 4 to 5. How do X-rays allow us to see inside objects and humans? This doesn't describe the process of how they're actually produced, it just tells us how we're allowed to actually see that. So pause and then get ready to have the answers revealed. Black equals 0% X-ray absorption. Bright white equals 100% X-ray absorption. Shades of grey between black and white indicate different amounts of absorption. The different shades of grey indicate different densities of material. Your next question to check, which is grades 4 to 5. Why and how is gamma radiation used to reduce food wastage and sterilise surgical equipment? So again, pause and then get ready to go through the answers, and then make sure you're green penning them, please. So, bacteria waste products cause food poisoning. Bacteria and viruses cause infection. Exposing food or surgical equipment to gamma rays kills 99% of disease-carrying organisms. Product equipment passed under a beam of gamma rays. Surgical equipment is sealed in plastic before exposed to maintain sterilisation. Question check for grades 7 to 8. Again, still have a go, because then you can see what a grade 7 to 8 answer looks like and the detail that's needed. Even if you put a couple of points, at least it would give you a couple of marks if you used to answer this in an exam question. So, explain how the process of ionisation can lead to cell death or cancer through damage to DNA, and what people whom have to work with ionising radiation do to monitor their exposure. So press pause, do as many key points as you can in bullet point form, and then I'll shortly share the answers. Removing electrons from a molecule/atom is ionisation. X-rays and gamma rays have sufficient energy to remove electrons from a molecule/atom. Ionisation of a living cell can kill high dose or damage the cell low dose. Damage is to the DNA structure, which is a part of the genes in a cell. Mitosis section of the cell cycle is when the fault is replicated or mitosis does not happen at all. Uncontrolled replication due to the DNA fault is called cancer. Wearing a film badge can indicate if a person has been overexposed. If overexposed person cannot work with the equipment for a period of time. So again, that clearly shows for grades 7 to 8 what is expected for that answer. For that question, not the answer. Another question check. Place X-rays, ultraviolet and gamma rays in the correct order of increasing energy, and state how harmful each is to living organisms. So on the table you can see low and high. This is grades 6 to 7. So pause, have a go, and then I'll be giving you the answer shortly. So you should have had ultraviolet, X-ray and gamma. Ultraviolet damages surface layer of organism, burns, ages, ionises, cannot penetrate deeper than surface layer. X-ray damages cells and kills cells in high doses by ionisation. Penetrates through most organisms, perhaps not a blue whale. Gamma, highest energy, damages and kills cells by ionisation. Penetrates through any known living organism. You've now covered grades 4 straight through to 8, so self-assess yourself. You can put all levels and put red, amber or green, or you can just state what level / grading you've achieved today. If you'd like to recap what you've actually learnt today, this slide just tells you a little bit in detail of what you should have learnt from this PowerPoint, so you can make a note of it. Additional material ahead if you'd like further reading. This slide shows how thickness affects absorption of gamma rays. So as the block width goes down, you can see the emerging ray density is 100%. As the block width increases, the emerging gamma ray intensity is obviously a lot lower. Early X-ray dangers. Taking an X-ray image with early Crookes tube apparatus in 1896, the Crookes tube is visible in the centre. The standing man is viewing his hand with a fluoroscope screen. This was a common method of setting up the tube power. No precautions against radiation exposure are being taken. Its hazards were not known at the time.